Let's take a look at an example of solving a system using Gaussian elimination. Here we have an example of a system, and the first thing I want to do is to turn this into an augmented matrix. So let's do that. Now I go and I look at this first column here, and I look and see, okay, I already have a 1 here, so that's great. And so now what I want to do is eliminate this 2 and this -1. So let's start by eliminating the 2. So I can do that by doing R2 minus 2R1. The first row stays the same, and so does the third row. The second row becomes 0 here, and now we have a -2 plus 2 is 0 here, and then I have a -1 plus 2 is a 1 here, and 3 minus 4 is a -1 here, and here we have a 3 minus 2 is a +1 here. Okay, so we have a 0 over here, so now we need to get rid of this -1. Well, what we can do is we can do R3 plus R1. So we can replace row 3 with row 3 plus row 1. Okay, well, we did not act on rows 1 or 2, so those stay the same. We did, however, act on row 3. So what does that change to? Well, we have a 0 here. We take 1 plus -1 is 0. -1 plus -1 is -2. 0 plus 2 is 2. -3 plus 1 is -2. Let me make this a little bit longer here. Okay, so good. We have zeros over here. Oh, we also have zeros over here. And our next leading entry is this guy. And so we need to get rid of the guy below it, this one right here. So what I can do is I can do row 3 plus 2 times row 2. And when I do that, I'm not acting on row 1, because row 1 is hidden right now, for instance, and I'm not acting on row 2, so that stays the same also. Row 3 becomes, let's see, -2 plus 2 is 0. Good, we wanted that to happen. 2 plus 2 times -1, so 2 minus 2 is 0. -2 plus 2 times 2 is 0 again. Okay, and this is in row echelon form with leading entries 1 and 1. So now let's see, well, let's go to turn this back into a system of equations. This becomes the system w minus x minus y plus 2z equals 1, and y minus z equals 1. Now we could do like 0x plus 0y plus 0z plus 0w plus 0x plus 0y plus 0z, or 0z equals 0, but there's no point in doing that. So this is our system. Thing to note is these guys are our leading variables. These are our leading variables because they correspond to the leading columns or leading entries. The other guys, x and z, these guys are our free variables. because they're the remaining variables. So now that we have our leading variables and our free variables, what we usually do is, just for the purposes of emphasizing that these are going to be parameters, we say, okay, we'll let x equals s, so that's our first free variable, and z equals t, that's going to be our second free variable. And then we write w and y in terms of those. So y is going to be t plus 1, and then w is going to be s plus t plus 1 minus 2t plus 1, which is s minus t plus 2. And so our vector form of our solution is going to be s minus t plus 2, s t plus 1, t.